today I am going to deliver lecture 2 on shear force bending moment, but due to some time constraint in my last lectures certain part was not covered. So, first I will continue with that part and then I will move on the part of shear force and bending moment. So, it is necessary also because those who are joining today, they can easily get the idea ki what was discussed in the previous lecture. So, just summarizing the things in 15 minutes, then we will move ahead towards the lecture 2 of shear force and bending moment. So, let me come to the lecture 1 part. Okay. So, I hope those who were available in that particular lecture, what I covered in that lecture, I covered something related to beam. So, I hope this particular thing is now clear ki what is a beam and how can we differentiate between statically determinate and statically indeterminate beam, because it is important one. This can be asked for a 2-mark question in exam to differentiate between statically determinate and statically indeterminate beam. And in last lecture I told you that sometimes the question can be of 5 marks where you have to draw the free body diagrams for the statically determinate and statically indeterminate beam. So, that is what we discussed. Okay. Then we discussed about various types of loads in that particular lecture. Okay. Point load, uniformly distributed load, uniformly varying load, point moment. So, these all things we discussed in the last lecture. Then various types of supports and support reactions. So, various types of support, it can be a simple support, it can be a roller support, it can be a hinge support, it can be a fixed support. So, all these supports and how do we deal with all these kinds of supports, that is what I have already discussed in my lecture 1. Okay. Then I started with one of the problem related to finding out support reactions for different loading conditions for different beams. So, that is what I discussed in my last class, but I had taken only one problem there. So, those who have any doubt related to these 3 topics, the beam, okay, let me select the pen. So, I discussed about beam, okay, statically determinate, statically indeterminate, loads, various types of support and support reaction. So, I request all of them to go through the lecture 1 after completion of this particular lecture. Then they will be definitely able to understand ki what is requirement for shear force and bending moment when we are going. Okay. So, one problem I had already taken. Let me go to that particular point ki what I discussed, all these things I discussed on that particular day. Okay. Okay. So, this problem I discussed in my last class. Now, I am coming to the next one, the problem 2. So, the problem is very much visible to you now. Okay. You can see the beam, which type of beam it is, which type of beam. Now, you can see the certain portion, the DF. Okay, pen is creating some problem. Okay. Now, I hope it is okay. Okay. So, the beam is shown to you, the beam is visible to you. Okay. Those who are available in the class, they can write all their comments in their chat box. Okay. So, the beam is visible, loading condition is also visible. Now, let me explain ki what exactly the loading condition and which type of beam it is. It is a overhanging beam because the certain portion of this beam DF is hanging. It is having different types of loads from A to B. It is having a uniformly distributed load UDL of 1 kilonewton per meter intensity. At point C, it is having 2 things. One is the point load of 4 kilonewton at point C and a point moment of 2 kilonewton meter intensity. At point F, you can see a downward load of 2 kilonewton and a horizontal force of 2 under root 3 kilonewton. So these are the forces. This is what the loading condition of overhanging beam. Okay. Now इनको नहीं देखना है हमें. We are not. These we will be finding out. Okay. So please don't worry. How we are going to calculate, that we will discuss. Okay. What are the type of supports? Here it's a roller support. Here it is a hinge support, and roller and hinge support, clear. So whenever we are replacing a roller support, now I am coming to the point, draw the free body diagram for this particular beam. So I have to remove this roller support. Whenever I am removing this roller support, it will be replaced by one vertically upward reaction, which is written here as RA. I am not knowing the value now. Okay, I am going to solve this. And whenever I am replacing the hinge support, it will be replaced by two reaction forces. One is the vertical upward reaction, which is written as RDV, and another one, that is the horizontal, that is the RDH. Why there will be two reaction forces? पिछले वीडियो में जाइए, definitely it will be clear to you कि why at the hinge support we are having two reaction forces, and at the roller why we are having one, and in which direction it will be. All these points were discussed in my last video in much detail. Here I am not discussing all these. Here we are concentrating on solving the problem and moving ahead towards the shear force and bending moment analysis of beam. Okay, so now it is clear. So what are the forces here? Loads, UDL, point load, point moment, downward load 2 kilonewton, horizontal force 2√3 kilonewton. Okay. This is the two-dimensional coplanar force system. Beam is a two-dimensional coplanar force system. For a two-dimensional coplanar force system, how many conditions of equilibrium we are having? The first one is sigma fx equals to 0. It means the algebraic sum of all the forces in x direction must be equal to 0. So what are the horizontal forces? Is there any horizontal force here? No. Then we can get one horizontal force here. This is RDH. This is RDH. Positive direction में है, positive ले लिया. Then another horizontal force which we are having, that is 2√3. The direction is opposite to RDH. So I can write here 2√3 equals to 0. So the value of RDH is now known to me. It will be 2√3 kilonewton. लिखा हुआ है यहाँ पर. Answer already available है. Okay. Now I am applying another equation, that is sigma Fy equal to 0. The meaning is quite clear. The algebraic sum of all the forces which are acting in bidirection. Algebraic sum means along with their sign. So magnitude and sign both we have to take. So what are the forces in bidirection? Let's start from point A. We are having a vertical reaction upward force. So this is RA. Then I am coming to the point D. Here we are having RDV. Okay. So there are two unknown reaction forces which we are having. Now I am dealing with the loads. So here the UDL. क्या करना है UDL का? UDL we have to convert it in a single point load. And how do we convert this? By taking the intensity and multiply it with the distance. So 1, that is the intensity, into 2. 1 into 2. This is what the net effective load of UDL. What will be the direction of this UDL? It will be downward. Definitely it will be downward. Here I am writing this is 1 into 2. 1 into 2 downward. So I am taking here as a negative. Now I am coming to the point C. Here again I am finding one force of 4 kilonewton which is downward. So I can write -4 here. Okay. Now I am coming to the point F. D already taken. D को ले लिया हमने. F point पर what we are observing? We are observing another load of 2 kilonewton which is downward, -2. Any other force in bidirection? I am not getting any other force in bidirection. So this is my equation number 2. इक्वेशन 1 हॉरिजॉन्टल फोर्स के लिए ऑलरेडी लिख दी थी, आंसर आ गया. हियर आई एम राइटिंग फॉर sigma Fy equal to 0. So Ra plus Rdv minus 1 into 2 minus 4 minus 2 equals to 0. Okay, is it clear? Any other force? Okay, how many unknowns are there? 1, 2. So is it possible to find out both the unknowns? No, because we are having only one equation. One is already done, RDH is available, but यहाँ पर RDH है नहीं. So I need one more equation. One more equation that I can take the moment about point A, or I can select the point D. D भी ले सकता हूँ, A भी ले सकता हूँ. D क्यों ले रहा हूँ? I am telling, because here two unknowns are passing, that RDH and RDV. So generally I want to minimize the size of my equation, that's why I am selecting point D. Otherwise conventionally कई लोग A point left side में ही लेते हैं, but it is our choice. Anywhere we can select the point. So I am taking D point for moment. So sigma md equal to 0. What is the meaning of this? Sigma md equal to 0. The algebraic sum of moments due to various forces which are acting. Various forces क्या क्या है? UDL है, point load है, point load है, point load है, support reaction है, support reactions है. Okay. So sigma md equal to 0. The meaning of this is the algebraic sum of all the moments about point D due to various forces equal to 0. And algebraic sum means clockwise tendency of rotation and anti-clockwise tendency of rotation. Both will be considered as positive and negative. It is up to us कि हम किसको positive ले रहे हैं और किसको negative. So let's start writing the equation. So first start from RA. This is the one force. So what it will be? RA, moment is force into perpendicular distance. So what is the distance between RA and D? It is 2, 2, 2. So RA into 6. RA into 6. This is the one. Okay. Then I am coming to what? यहाँ से चलते हैं. Okay. RDV. So RDV, will there be any moment because of RDV about point D? No. It is force into perpendicular distance and RDV is passing through what? Point D. So the perpendicular distance between RDV and point D is 0. So there will be no moment because of RDV. Now I am taking the RDH. RDH is also passing through. RDH, the horizontal force at point D, it is also passing through point D. So it will also not generate, it will not also trying to rotate the point D. Okay. Then I am coming to, so RDH is done, RA is done, RDV is done. Now I am coming to the UDL, 1 into 2. So let's, मेरा जैसा तरीका है, मैं सबसे पहले load लिख देता हूँ. So 1 into 2, this is what the load, this is not the moment. Okay, this is the load. What is the perpendicular distance of this load from point D? So this is 1 into 2. Let's यहाँ A से B के बीच में देखें, 1 into 2. This is the net effective load of this UDL. Where it will be effective? It will be effective at the midpoint of AB. It means it is 2 meter. So 2 by 2 ये होगा हमारा, and 2 by 2 this is also 2 by 2. I hope it is visible. Okay. Now this 1 into 2 which is at the midpoint of AB, how far it is from D? What is the perpendicular distance? So 2 plus 2 plus 2 by 2. 2 plus 2 plus 2 by 2. What will be the rotational tendency? The rotational tendency because of this about point D, how it is? This is anti-clockwise. RA की वजह से clockwise था, इसको positive लिया है. So now I am taking this as a negative. It is done. Now I am coming to the 4. Now I am coming to the 4 kilonewton which is at point C. 4 kilonewton, the moment due to this about point D, it will be minus 4 into, what is the distance? 2. 4 into 2. Okay, very good. It is 4 into 2. कोई issue नहीं. Now I am coming to this 2 kilonewton. This is 2 kilonewton at point F. 2 kilonewton. How far it is from here? It is at 1 meter. 2 into 1. 2 into 1. What is the tendency of rotation because of this 2 kilonewton? It is clockwise. Positive I will be taking this, positive I am taking this. Okay, 2 into 1. थोड़ा सा writing आपको हो सकता है ऊपर नीचे हो because of this pen. Okay, but wherever if you are not getting the thing, please write in chat. Okay, so 2 kilonewton. Now another force is there, 2 root 3 kilonewton. So 2 root 3 kilonewton. This is passing through point D. So will it create any moment about point D? No. Other than all these forces, I am having one point moment also at point C. And what is its tendency? What is its tendency? It is anti-clockwise. It is anti-clockwise. So I will be writing this also. Now this is the complete moment equation. So now we are having two equations, sigma Fy equal to 0, Ra plus Rdv minus 1 into 2, which is the Udl minus 4 minus 2. Okay, in sigma Fy, Rdh already done. Point D के about moment, Ra into 6, force into perpendicular distance हो गया, then 1 into 2, this is the Udl, it is 2 plus 2 plus 2 by 2 distance away from the point D, then 4 kilonewton which is at 2 meters of distance, 4 into 2, then at point F it is having 2 into 1, then a point moment. So these are the, mathematically I can solve these, both of these equations, and I can easily find out the answer for this particular. So what are the answers coming? May I wait for some time? If anyone is solving, please solve these two equations if anyone is solving. Okay. If you are solving this particular equation, okay, then tell me the answer, otherwise I will be telling. May I wait for some time? Those who are available in the lecture, they can write the answer. Okay, please. If it is not visible, equation clear hai? If equation is not clear, then also please tell me. Okay, no worry. So here you can see the answer. RDH 2 root 3 kilonewton. RA which is coming out by solving the equation is already written. मैंने भी लिखी हुई है already मेरे पास. I am having the solution also for this particular. So RA into 6 plus 2 into 1, this the same equation is there, and RDV, that is the 5 kilonewton. Okay. One more question I want to take here. Okay. So one slide can I insert here? May I insert one slide here? Just a minute. Let me. मैं यहाँ पर उस स्लाइड को इंसर्ट कर लेता हूँ. One more problem I want to discuss here with the support reactions. Okay. One more problem in which we will be finding the UDL and UVL combination also. Okay. So the problem is like this. Okay. There is a beam at this particular point. We are having a roller support. At this point we are having hinge support. Okay. From here to here there is a UDL, of 1200 Newton per meter intensity, and here we are having a UVL which is reaching up to the value of 2800 Newton per meter. the distance from here to here, it is 4 meters, and from here it is 6 meters. This I can write as point A, this I am writing as point B, and this I am taking as point C. Okay. So, it is clear. So, there is one question, the question is visible to everyone. Okay. The question सीधा सीधा सही सही दिख रहा है. Please confirm me. Those who are available in the class, please confirm me. Okay. कि question is visible. Please write something in the chat box so that I know कि class जागी हुई है. Otherwise सो जाएंगे हम. फायदा नहीं होगा lecture का. ठीक है ना. So if you are here in the class, write कि question is visible. The 1200 Newton per meter intensity is there. Then from 1200 it is increasing from point C to B up to 2800 Newton per meter. And at point A the support is roller, at point B the support is hinged. Okay. Now let's try to do this particular problem. Okay. The 4 meter and 6 meter the distances are given. Okay. At point A the roller support is there. Purposefully मैंने ये क्वेश्चन लिया है जिससे ऐसा ना लगे कि रेडीमेड क्वेश्चन है. ओके. समटाइम्स बिल्कुल लाइव एकदम हमें होना चाहिए. ओके. सो आर ए is here. Okay. By removing roller we can get one upward reaction force. At point B there will be two reaction forces, RBX and RBY. कोई इशू नहीं. No. How many conditions of equilibrium we are having? How many conditions of equilibrium for this particular? Sigma Fx equal to 0. How many horizontal forces we are having? We can observe only one horizontal force, because all these loads, either it is a point load or it is a UDL or UBL, ये सारे कैसे हैं? Vertically downward. So we are not having any external horizontal force. So RBX कितना होगा? RBX equals to 0. This is the first equation. Okay. Now I am trying to write another equation, that is sigma Fy equal to 0. Sigma Fy equal to 0. Okay. Very good. Sigma, कुछ लोगों के कमेंट आए. वेरी गुड. या सुने, एटलीस्ट बात समझ आ रही है, सुन रहे हैं, जागे हुए हैं. सो आई एम वेरी हैप्पी. दोज और भी जो लोग हैं वो जागे हुए रहें. नाउ सिग्मा Fy इक्वल टू 0. सिग्मा Fy इक्वल टू 0, इट मीन्स बाई डायरेक्शन में आई एम हैविंग टू फोर्सेज. वन इज RA प्लस RBY. These two are the unknown support reactions जिनको निकालना है हमें. What are the other forces? First I am saying this is the UDL, and इस UDL को, UBL को, it is like a trapezium. It is like a trapezium. I am dividing in two parts. So the second part will be the UDL and the third part will be the UBL. So from 1200 to 2800 it is increasing from point C to B. So I am dividing it in two parts. Second part will be the UDL, which you can see here, and the third will be the UBL. So let me do this here. What I am trying to do. This is the 2 and this is what the UBL will be the third one. Okay. Now I can easily handle with this particular question. A to C क्या होगा? UDL है, so minus 1200 into 4. No issue at all. Now I am coming to the second one. What can I write? Minus 1200 into 6. ये कहाँ से कहाँ के लिए लिखा है? From C to B. किसी को ये लग सकता था कि सर ये पूरा ले लेते 1200 into 10. ले सकते हैं, कोई इशू नहीं है उसमें. But in general I divide. जितने छोटे छोटे components में I can divide so that the handling is easy. So that's why I have taken it in this particular manner. Then UBL I have to handle. The third load. थर्ड लोड क्या होगा? ट्राइंगल है, सो द एरिया ऑफ द ट्राइंगल. व्हाट विल बी द एरिया ऑफ द ट्राइंगल? हाफ इनटू द डिस्टेंस इज हाउ मच? इट इज 6. 1200 2 के साथ चला गया, ऊपर कितना बचा? 1600. एम आई ओके? Is this equation okay? Is this equation okay? कोई issue तो नहीं? RA vertically upward reaction, RBY vertically upward reaction, 1200 into 4 first load of UDL, 1200 into 6 between C to B again UDL, 1200 rectangular है, then UBL from C to B from 1200 to 2800, so this portion is 1600, so which I am taking minus half into 6 into 1600. This is the second equation. Now I am writing the equation for moment. Sigma MA equals to 0. Sigma MA equals to 0. Okay. The procedure is same. I will be taking load one by one. All these loads are available in these two equations. ये दोनों equation में सारे load जो इस beam पर हैं, known और unknown, वो सारे available हैं. So now I am taking the moment due to all these loads about point A. Is it okay? RBX already it is 0, so it will not be generating any moment about point A. Now I am coming to the RA. RA, it is passing through point A, so the perpendicular distance is 0, so it will not generate any moment about point A. Now I am coming to the RB by. The perpendicular distance of RB by how much? जिनको समझ आ रहा है वो लिखें RB by की perpendicular distance कितनी है, please. Those who are getting, what is the distance of RB by from point A? Okay, मुझे तो clearly दिख रही है, it is 10. What will be the tendency of rotation? The tendency of rotation RB by, जो tendency of rotation होगी इसकी like this. How it is? Anti-clockwise. माइनस ले लेता हूं. Okay, point A के about moment equation लिख रहे हैं. Now I am coming to the second one, the 1200 into 4. 1200 into 4. 1200 into 4, what it is? 1200 into 4 is the UDL. Where it will be effective? 1200 into 4. This is the net effective load of UDL. Where it will be effective? This is, I am writing 1200 into 4. Where it will be effective? इतना सजाने की आपको जरूरत नहीं है. This is what I am doing only for explaining you. Otherwise, you can directly write. So 1200 into 4. How far it is? Obviously, it will be at the midpoint of this. So 4 by 2 from A and 4 by 2 ये भी होगा. मैं मोमेंट कहाँ ले रहा हूँ भाई? A point के about. So what will be the distance? 4 by 2. ध्यान से देखते जाइएगा. Wherever you are getting any difficulty, please write in chat box. Okay. 1200 into 4 into 4 by 2. This is tendency of rotation clockwise. I am taking it positive. Now I am coming to the second UDL. Okay. Second UDL क्या लिया है मैंने? 1200 into 6. 1200 into 6. 1200 into 6. इसको मैं यहाँ शो कर देता हूँ. This is UDL. 1200 into 6. How far it is? 4 plus midpoint of 6. 4 plus midpoint of 6. So 4 plus 6 by 2. 4 plus 6 by 2. Yes. And the tendency of rotation क्या होगी इसकी भी? Tendency of rotation will be clockwise. Tendency of rotation will be clockwise. Okay. Now I am coming to the last one. This is UBL. Okay. Half into 6 into 1600. ये लोड है, ये पूरा लोड है UBL का. Okay. From C to B. How far it will be? How far it will be? कहाँ होता है भाई UBL? UBL is effective at 2L by 3. 2L by 3 कहाँ से? 0, जहां से स्टार्ट हो रहा है. 2L by 3 from this point. Okay. तो डिस्टेंस कितना होगा इसका? A पॉइंट से 4 plus 2L by 3 and L is how much here? 6. So 2 into 6 by 3. आ नहीं रहा वहां पर. 2 into, मैं इधर लिख दूं इसको, सॉरी इसको कट कर देता हूं. ओके, यहां लिख देता हूं मैं इसको. 4 plus 2L by 3 equals to 0. Equals to 0. Is it okay? Is it okay with everyone? So this is what the equation. आप इन्हें सॉल्व करें, सॉल्व करके आंसर निकालने की कोशिश करें प्लीज. जो भी तुरंत इसको यदि सॉल्व करेंगे तो यू विल बी गेटिंग सम आंसर. आंसर इफ यू आर फाइंडिंग आउट देन आपको भी अच्छा लगेगा, बिकॉज दिस वी आर मेकिंग द बेस फॉर shear force and bending moment. And my dear friends, all those who are in first year and second year, there may be question for finding out support reaction itself also. It is not ki only the SFD BMD will be asked, only you have to draw the shear force diagram and bending moment diagram. Second year students, those who are dealing with structures, either it is a beam or it is a truss, in both the cases you have to find out the support reaction. If your support reaction is not okay, then your whole answer is in doubt. Your whole question is in doubt. In first year also we are having the shear force bending moment. So obviously the support reaction के बिना सारा question गलत है, because shear force and bending moment are caused by external forces, and in external forces support reactions are one of them. So is anybody solving? यदि सॉल्व करें जल्दी से आंसर बताएं भाई. If anyone is solving, how much is RB by, how much is RA? If anyone is done with the answer, please write in the chat box. Okay, I am waiting for 30 seconds. Please. थोड़ा सा गलत है अभिषेक. According to me, RB is 9840 and RA is 6960. RB क्या बोला मैंने? 9840. 98 RB by is 9840. न्यूटन लिया है? Yes, तो न्यूटन. And RA is how much? RA is, it is coming out 6960. According to me, this is the answer. If you are okay with the equation, equation में कोई इशू नहीं होना चाहिए. आंसर कैलकुलेशन एरर हो सकती है. Though it is expected कि answers must be 100% accurate and precise, but anyways, first the concept part is okay. Then after practicing some more questions, you will be getting the right answer also. Okay. Okay. So ईशान is writing something कि yes sir, answer ठीक मिल गया है, उनका आंसर ओके हो गया. ओके, क्या इसको थोड़ा सा चेंज कर लें क्वेश्चन को? नाउ आई एम ट्राइंग टू चेंज दिस क्वेश्चन. rather than writing the equation, moment equation about point A, let's start writing the equation about point B. Okay, so मैं दोबारा इस क्वेश्चन को ड्रॉ कर देता हूं. मेरे पास मैं रीओपन कर देता हूं एक बार, ठीक है ना. लेट मी, ओके, सिर्फ ओनली फॉर द पर्पज ऑफ प्रैक्टिस, ओनली फॉर द पर्पज ऑफ प्रैक्टिस आई एम डूइंग दिस. ओके, क्या था क्वेश्चन? आप लोग लिखने की कोशिश करें, बिकॉज आफ्टर दैट आई डोंट थिंक कि आपको कोई इशू आना चाहिए. आई डोंट वांट दिस. बिल्कुल, ये मेरा रहा UDL, ये रहा UVL. okay, now I hope it is quite visible. This is UDL, and the intensity is 1200 Newton per meter, and it is reaching up to 2800 Newton per meter. This length is 4 meter from A to C, and C to B it is 6 meters. Only equation I am writing. Okay, only equation for moment. Sigma m b equal to 0. क्यों लिख रहे हैं? पर्पज है. द पर्पज इज दिस बिकॉज आई वांट टू UVL को थोड़ा चेंज कर रहा हूं मैं. Okay, so हमारी practice हो जाए. It is not necessary कि always you will be getting the increasing UVL. Okay, it can be a decreasing UVL also. Okay, sometimes. So only for the practice purpose we are writing. Otherwise, our answer is done. Okay. So again, this is the 1, this is 2, and this is 3. Okay. Let's start. This is RA. ये सारी चीजें थी मेरे पास. And sorry, this is RBY and this is RBX. Okay, कोई दिक्कत नहीं. Is it okay? चलिए अब चलते हैं भाई. I am not writing sigma fx and sigma fy equal to 0. I am only writing sigma mb equal to 0. So the first one, RA, let's start from RA. RA into the perpendicular distance from point B, it is 10. RA into 10. Now RBX and RBY both are passing through point B. So no moment will be generated because of RBX and RBY. Is it okay? कोई perpendicular distance नहीं है तो कोई moment नहीं होगा. Now I am coming to the UDL. UDL is how much? It is 1200 into 4. 1200 into 4. How far it is? 1200 into 4 कहाँ होगा ये? It will be at the midpoint. 1200 into 4. It will be at the midpoint. Okay. So this distance will be how much? This distance is 4 by 2. How far it is from point B? It is 6 plus 4 by 2. 6 plus 4 by 2. The tendency of rotation about point B, it is anti-clockwise, negative I am taking. Because of RA, it is clockwise tendency of rotation about point B, so I am taking it as a positive. Now I am coming to the second UDL, which is 1200 into 6. 1200 into 6, it will be at the midpoint of 6. B point से कितना दूर होगा ये? It will be at 6 by 2. So this is load. I am writing it here 6 by 2. The tendency of rotation because of this, again anti-clockwise, minus. Now UVL. UVL I am knowing how much it is? Half into 6 into 1600. This is the UVL. Okay, this is the UVL. Half into 6 into 1600. Nitin Tiwari लिख रहे हैं कि done. Very good. Nitin Tiwari, are you from S14 section? So if he is doing good, then very good. I am very happy. Okay. So half into 6 into 1600. अब इसकी distance कितनी होगी B point से? Let me clarify. Those who are knowing, very good. Those who are doing this type of question first time, for them, UVL, if I am converting it in a single point load, this is the single point load. It is 2L by 3 from here and L by 3 distance here. कहाँ ले रहा हूँ मैं moment? इस position पर. So the distance is L by 3. How much it is? L by 3. 6 by 3. Tendency of rotation क्या होगी? Anti-clockwise. So minus already there. 0. Now you can find out. Okay, Nitin Tiwari from ME2. Very good. Thank you, Nitin. So I am happy at least you are attending the lecture and doing the question. Good. You can find out RA here. Okay. So I don't think there is any problem in this particular type of problem. Ki RA, RB, RBY, RBX, we can easily find out support reactions here. Okay. So now I can move towards the shear force and bending moment. Okay. So let me start the shear force bending moment. So okay. So up to now क्या क्या डिस्कस कर लिया? Again I am beam, various types of load, various types of support reactions, and 3-4 questions we did on finding out the support reactions. Now I am moving towards the what? I am moving towards shear force and bending moment. The lecture 2 actually starting from here, shear force and bending moment. What basically it is? Shear force is basically what? Shear force is, in last class also, in last lecture also I discussed this particular thing. Shear force and bending moment are the internal resistances or internal resistive moments which beam material or beam cross section offers against the failure. For what purpose we are putting the beam? For the purpose of supporting the load. So we don't want it should fail. We want it must resist the certain amount of shearing force as well as the moment. Because load क्या करेगा? If the loads are there, beam को define किया हुआ है कि beam is a horizontal structural member which support transverse load. So what this transverse load will do? This transverse load will try to shear the beam or it will try to bend the beam like this if the moment is there. So these are the two effects which a beam can receive from the external loads or support reactions, जिसकी बात हम lecture 1 में अब कर चुके हैं. Okay, so beam material must be like this to offer the internal resistances against the shearing action or the bending action due to external load. So this is what the first thing, the concept of shear force and bending moment in beam. What is written over here? When the beam is loaded, the internal forces and moments are developed and these are termed as shear force and bending moments. Okay, so whenever the beam is loaded, beam means what? Let me draw the beam. जहां भी जिसको भी समझ नहीं आए प्लीज हम चैट बॉक्स में लिख सकते हैं. दिस इज द बीम. बीम की डेफिनेशन के हिसाब से एम आई करेक्ट? ओके, मैं इसको सपोर्ट भी कर देता हूं. हियर आई एम पुटिंग द रोलर सपोर्ट, हियर आई एम पुटिंग द हिंज्ड वन. सो दिस इज द बीम. लोड मे बी ऑफ एनी काइंड. हियर आई एम पुटिंग ओनली द पॉइंट लोड. ओके, सो द बीम. अब मैं इसको shear force क्यों कह रहा हूं? I am coming to that particular point. Why I am not saying it the load or the force? Why it is a shear force and what effect it is going to produce here? Okay, I am taking one section here. Okay, let me draw this. This force, the load which are the transverse, कैसे हैं ये? These are parallel to the transverse plane. This is the transverse plane. This is the transverse plane. So the load, the externally applied load is parallel to the transverse plane. So obviously the resistance offered by beam material will also be parallel to the transverse plane. And if the force or the load or the reaction is parallel to the surface, parallel to the plane, we call it shear. We call it the shearing action. So that's why it is termed as shear force. Okay, shear force. Okay, this is now the term must be clear why it is shear force. Now I am coming to the bending moment. What can happen with the beam? Again I am drawing the beam. Okay, ये इसका मैंने सेंट्रोइडल एक्सिस दे दिया. ओके, सो इट कैन हैव द बिकॉज ऑफ द लोड इट कैन हैव द बेंडिंग मोमेंट्स आल्सो. ये क्या कोशिश करेगा? इस बीम को बेंड करने की कोशिश करेगा. इट विल ट्राई टू बेंड द बीम. So there are two effects which have to be resisted by the beam material, which has to be resisted by the beam cross section. One is the force which is parallel to the transverse plane. Another effect because of the external load, it can cause the bending also. So these two effects must be resisted by beam. So that's why we are going to study about shear force and bending moment. That's why we are interested in shear force and bending moment. Okay, so I hope this particular thing is clear. It's not the externally applied force, it is the internal resistive forces. Shear force and bending moment, internal resistance which a material or beam is offering, cross section of beam is offering. Okay, Here you can see one beam. Now कैसे निकालेंगे? How we are going to find out the shear force and bending moment? So here you can see in the diagram A, you can find R1, R2. These are the support reaction at point this. P1, P2, P3. These are the loads. Okay, I am taking one section AA at certain distance from point R1, from the distance this. Okay, what I am trying to do, consider the beam shown in figure which is supporting at the loads P1, P2 and P3 is simply supported at 2 points, creating the reactions R1 and R2. Take a section at a section AA. AA is one of the section. What I am trying to do, now let's assume that the resultant loads and the reactions on the left of AA is F, vertically upward, and entire beam has, क्या कहना चाह रहे हैं, what they are trying to say here. I have taken a beam and taken a section AA. Now take the sum of all the forces which are on the either side of the section plane. So here I am having how many forces? P1, P2, R1. P1, P2 and R1. These are the three forces. Take the algebraic sum of all these forces. Algebraic sum I am taking for all these and it is coming out F. Obviously at this particular section, for the equilibrium at this section, there must be equal and opposite force on the other side of the section plane. So that's why it is written over here कि loads and reactions to the left of A is F, and for the equilibrium the resultant of forces to the right of A must also be F. This is what the shear force. This is what the shear force. इसको अभी मैथमेटिकली भी करके देखेंगे. This force F is known as shear force. Now let's please understand what basically the shear force is. क्या कहा अभी? On the left, now I am taking the section here. On the left side, here I am getting a force F. I am assuming this. Mathematically I will prove this. Will it be equal or not? Okay. I am having, let's assume the algebraic sum of P1, P2 and R1 is F, perpendicularly upward. Obviously I am talking about the equilibrium of the beam. So on the other side also there will be downward force. There must be downward force. Both these forces क्या होगा? One is trying to move upward, another one is trying to move the beam downward. This will create the shearing action. This will create the shearing action. And the force is also how it is? It is parallel to the transverse plane. So this is what the shearing force, which is what the, this is what the shearing force. Just like a scissor. यदि मैं scissor का example लूँ, the one arm is going down, another one is coming up. So this is what the shearing action. Okay. तो क्या करती है ये shearing action? It is cutting the paper. So if the beam is having the value of external loads is more than the shearing force which a beam material can offer, then there is a possibility of shearing action here. Okay. So this is what the one thing, shear force. Now I am coming to the definition, how mathematically we are going to calculate this. So at any section of beam, at any section of the beam, the shear force F is the algebraic sum of all the lateral component. Lateral component means perpendicular to the length, perpendicular to the length. So at any section X, at any section X means at any section, जहाँ से मैंने divide कर दिया beam को, cut कर दिया. So at any section X of a beam, the shear force F is the algebraic sum of all the lateral components of the forces acting on the either side of the section plane. लेफ्ट साइड में हो या राइट साइड में, जितने भी फोर्सेज हैं वर्टिकली अपवर्ड और डाउनवर्ड, द सम ऑफ ऑल दी फोर्सेज उस पर्टिकुलर सेक्शन पर shear force होंगे. हाउ दीज विल बी ट्रीटेड? साइन कन्वेंशन क्या होगा? इफ आई एम टॉकिंग अबाउट द फोर्स, देन ऑब्वियसली वी मस्ट हैव सम साइन कन्वेंशन. सो इफ द रिजल्टेंट फोर्स ऑन द लेफ्ट साइड ऑफ द सेक्शन प्लेन इज अपवर्ड, it will be considered as positive. Similarly, on the right side of the section plane, downward force will be considered as positive. Simple सी बात, both will produce the same effect. दोनों मिलके ही तो इफेक्ट प्रोड्यूस कर रहे हैं. जस्ट लाइक अ सीजर, one arm is going down, one is coming up. So the resultant force which is in upward direction and towards the left hand side of the section plane, positive shear force. Similarly, on the right side of the section plane, it will be treated as downward shear force will be treated as positive. Okay. दूसरा भी देख लें. दूसरा, the resultant force on the left side, if it is downward, it will be treated as negative. On the right side, if it is upward, it will be treated as positive. So here we are ending today's lecture. So we have covered very few or little things about the shear force. What basically? Let me summarize. Shear force is what? When the beam is loaded with certain loads, external loads. These external loads are what? These external loads can be a point load, UDL, UBL, and because of these loads, there will be reaction forces. So these are the external causes, which has to be supported, which has to be resisted by the beam material or beam cross section. So the forces which are parallel to the transverse plane for resisting the effect produced by external causes, these are known as shear force. कैसे निकालेंगे? Just take a section and take the algebraic sum of all the vertical forces on the left side or on the right side. If left side it is coming upward, then it is positive. On the right side, if it is coming downward, then also it is positive, because both are producing the same result. And vice versa is also true. If the left side it is downward, on the right side if it is upward, then it will be treated as negative shear force. So in the next lecture I will be covering this complete chapter, shear force and bending moment, and we will be starting some questions also. But please, before coming to the class, please watch these videos, lecture 1 and lecture 2. lecture 2 में भी थोड़ा सा ही हुआ है, but definitely इसको थोड़ा और आगे बढ़ाएंगे. So please come prepared, so that the things will be easier to learn, things will be easier to understand. So thank you very much for watching the video. Thank you very much.